Imagine leaving Earth on a Monday and walking on the red planet by Thursday morning. We are ditching the grueling 7-month transit for phased array laser thermal propulsion, a technology that bridges the interplanetary gap at impossible speeds. It isn't science fiction anymore. It is how we finally conquer our solar system. How can a beam of light propel us across millions of miles in mere days? This isn't just about faster travel. It's about fundamentally rethinking humanity's place in the cosmos. By the end of this journey, you'll understand how laser propulsion could unlock the solar system, making interstellar travel not just a dream, but a destination. At its heart, this revolutionary idea is simple. Instead of carrying all our fuel, we leave the energy source behind. Think of it like a sailboat. You don't carry the wind, you harness it. Here, we harness light. An immense laser array on Earth fires a powerful beam at a specially designed spacecraft. This beam either pushes the ship directly using photon pressure or heats a propellant to create thrust. Either way, the heavy fuel stays on Earth, allowing the spacecraft to be incredibly light and agile. Across the cosmic ocean, where stars are born and die, humanity has always sought to reach beyond its cradle. For decades, our voyages have been powered by the roaring might of chemical rockets. These engines, burning liquid hydrogen and oxygen, have been engineering marvels, propelling us to the moon and beyond. But they've reached their theoretical limits. To reach Mars, a rocket must carry an astronomical amount of fuel, often 90% of its total mass. This dead weight drastically slows us down, forcing us into long, arduous journeys. Could we ever truly explore the cosmos if every step required such immense baggage? Like ancient lighthouses guiding ships across an endless sea, the concept of phased array lasers redefines terrestrial power. Imagine a network of 100-megawatt laser banks, not just one, but thousands, spread across a continent. These aren't destructive death rays, they're precision instruments, meticulously synchronized. Pioneered by visionary scientists like Philip Lubin, this phased array technology allows thousands of small modular laser units to combine their energy. They create a single, incredibly powerful, concentrated beam of light that can span millions of miles. This beam exerts photon pressure, a gentle yet constant push from light particles. It's like an invisible hand, constantly accelerating the spacecraft. What boundless possibilities open when the very fabric of light becomes our engine. In the silent ballet of orbital mechanics, where every second counts, time itself becomes a precious commodity. The traditional 210-day journey to Mars is a marathon, testing the limits of human endurance. Astronauts face months of muscle atrophy, bone density loss, and dangerous radiation exposure. But with laser propulsion, that changes everything. We're talking about a radical 3-day sprint. This is achieved through high delta V maneuvers, the ability to change velocity dramatically and quickly. Instead of a long, looping trajectory, we can take a much more direct, high-speed path. Imagine the profound impact on human health and mission costs. What does it mean for humanity to truly shrink the vastness of space? The vessel itself, a shimmering whisper in the void, must be unlike any spacecraft we've ever built. Its most crucial component, an inflatable heat exchanger. This massive yet incredibly light sail captures the laser energy, converting it into thrust by superheating a propellant, like hydrogen, to extreme temperatures, creating a powerful jet. But hitting a target the size of a spacecraft, moving at relativistic speeds across millions of miles, requires unimaginable precision. Sophisticated tracking systems, constantly adjusting for planetary motion and light speed delay, are essential. And then there's the return journey. How do we decelerate at Mars without another laser bank waiting for us? This remains a formidable engineering challenge, potentially requiring a small onboard nuclear thruster or a laser braking maneuver using the same system. This isn't just about getting to Mars faster. It's about fundamentally reshaping our civilization. Imagine not just Mars colonies, but orbital resource extraction, asteroid mining becoming economically viable. This technology could even pave the way for interstellar probes, pushing tiny light sails to a fraction of the speed of light, reaching Proxima Centauri in decades, not millennia. It transforms us from planetary inhabitants to a truly spacefaring species. Now, let's clear up some cosmic dust. A common misconception is that these lasers would simply burn up the spacecraft. Not true. The energy is either reflected for photon pressure or absorbed by a heat exchanger designed to safely convert that energy into kinetic thrust. It's about heat transfer and momentum, not destruction. Another myth. It's just a bigger rocket. No, it's a paradigm shift. We're decoupling the energy source from the vehicle itself. And here's the mind-blow moment. The same principles could one day propel us close to the speed of light. Imagine a probe weighing just a few grams, but pushed by gigawatts of laser power. The universe, once impossibly vast, begins to shrink. So what have we discovered on this journey? Laser propulsion is the radical new engine for space travel. It ditches heavy chemical fuels, pushing ultralight spacecraft with beams of light. This technology promises to slash travel times to Mars from months to days, transforming human space exploration. It moves us beyond the chemical era, making the solar system our backyard and perhaps, one day, the stars our next destination. We've gone from imagining walking on Mars on Thursday to understanding how it might actually happen. We are only at the beginning of this incredible story, a new chapter in humanity's cosmic odyssey. If this vision of the future ignited your imagination, hit that like button, subscribe for more journeys into the cutting edge of science, and tell us in the comments, what part of laser propulsion surprised you the most?